Rather than verifying that a point is on the parabola, this time Sasha and Keoni are told that a particular point is on the parabola and that its y value is 5. Their job is to find the x value for that point.
Could you mark the point on the parabola where y will be 5?
All right, so since we know it's going to be 5, it'll be along this, somewhere along there.
Can you mark the point on the parabola that would have y equals 5?
Right here.
Okay. And so what I want you to do is figure out what the x value will be for that point. If y is 5.
If y is 5, well, let's see how many spaces this is away from the directrix. So, go ahead.
Oh, here we go. Okay. So, just color it. Okay, 1, 2, 3, 4, 5, 6.
So, it's 6 units away from our directrix. So, we want to see that it's 6 units away from our focus. Okay, so what we've been doing was the Pythagorean theorem. So we would find this distance, and then this distance. So this would be 4. But what's that?
Exactly.
What's
so that's, we can just leave that as like b squared then.
B squared?
Because we know this is going to be 6.
True.
Because we already proved it.
You.
Nice. Okay.
Sweet.
So now it's
6,
a
okay.
squared.
So it'd be 4 squared, right? Or would it be?
Whatever.
Yeah, it'd be 4 squared.
Plus b squared.
Okay. Plus b squared equals 6.
Squared.
Oh, squared. You're right. Okay. So 16 plus b squared equals 36. Subtract 16 from both sides. And get b squared equals 20. 20.
20. I can add or subtract.
Wait, but then
Square root.
square root both sides, you get b equals square root of 20.
Would you like to find out what square root of 20 is? You can use the calculator.
Isn't that the right one?
Let's click right there.
Isn't that what you keep clicking?
What?
Okay. So it says it equals 4.5.
And that would be,
Your x value.
or the distance between there.
Okay.
Can you show me with your little cursor there which distance you're pointing to? You said it's the distance between here.
The distance between this point and this point
Okay.
is 4.5.
It's 4.5. Now, can you write the coordinate pair for the point that is on the parabola when y is 5?
Okay, 4.5. That is a point, comma 5.
And can you?
And it's right there.
Okay. All right. So I think you figured out your first point.
Yay!
Yes.
And it seems like you're starting to create a method.
Sasha and Keoni are beginning to develop an important method. First, they use the coordinate grid to find the distance between the point and the directrix, which was 6 units. By the definition of a parabola, the distance from the point to the focus must also be 6 units. Sasha and Keoni saw the line connecting the point and the focus as the hypotenuse of a right triangle, which means they were able to use the Pythagorean theorem. They found the length of one side of the right triangle by using the coordinate grid to count units. The length of the other side is what they are trying to find. Sasha and Keoni pointed out that this distance is the b value in the Pythagorean theorem, as well as the x value of the point on the parabola. By using algebra, they found the x value of the point on the parabola is about 4.5 when y is 5.